Hi, hello, good morning. Good morning, everyone here at NUS University Town, as well as those joining us online. Welcome to the Skills Future Festival at NUS 2025. I'm Alifa, your MC for the workshop on AI, data, and IoT. We are delighted to have Associate Professor Lokesh from the Singapore University of Social Sciences with us today. Let's give him a warm of welcome.
You.
Welcome.
Hey, good morning. Thanks for taking time to attend the Skills Future event organized by NUS, and thanks for those who are joining online too. My name is Lokesh. I'm from SUSS, Singapore University of Social Sciences. Our university vision is a university that inspires learning for life and impacts life. And a quick intro about our university. We currently have 3,000 over full-time students and more than 12,000 students doing part-time programs with us. We also have CET courses for working professionals and those who plan to upgrade their qualifications by stacking modular courses. So we have over 12,000 CET learners and online learners. So faculty-wise, we have like more than 270 full-time faculties, and we also leverage on the professional firms, industry, and academia to teach our courses. So we have more than 1,000 associate faculty members. And we currently have 5 schools and a college. So these are the schools I'm just going to quickly run through. I'm from the School of Science and Technology. We also have a college of interdisciplinary and experiential learning. So another school is coming up. I think you had already seen it in the news, but it is not yet officially listed in the website. Okay. So coming to the topic, I know some of you, if you have already have hands-on experience with AI and stuff, maybe some of the items that I'm going to cover is going to be what you already know. But if you are looking to get started into this area, or you are just recently started in this area, then maybe this presentation could shed even more insights into it. Okay? So, so for the 3 terms, I'm just going to give you the examples of AI, data, and IoT. These terms are like omnipresent that we don't even realize it. We are using it day in and day out. So for AI, many of you would have used voice assistants. For example, your phones has Siri, even your home has Siri or Alexa speakers. We have email spam filters that we everybody uses email. So these emails now come with automatic spam filters. There are like we access the social media, the news feeds, and so on. Based on what we read, then the system is able to recommend the news and feeds to us. And these are the things that's happening behind, but we don't know that it has been or it is being currently done with the help of AI. So the data, again, the watches, the smart watches that you use, the phones generates a lot of data. The whatever the clicks that you do on your phone is captured as data. Whatever the parameters, the watch or any smart devices that you wear on your body, it collects data and then it is being used for processing and make some useful recommendations and gets useful insights about you or about what's the plan. It gives you maybe a health transition plan for a better well-being and so on. IoT devices are also quite omnipresent. Your smart TV, smartphones, the RFID, the security systems, all functioning because of IoT. So these 3 terms are there like omnipresent. We are using in, day out, but just that we don't explicitly perceive them. Okay. So what is AI? So AI by definition is the ability of any computer or machine to perform tasks that can mimic human intelligence. Okay, so AI enables like machines to think, learn, act like humans. That is like an overarching umbrella which encompasses everything. Okay, so if you ask, again, this diagram was generated using ChatGPT. I purposely there are diagrams, Venn diagrams in the internet, but I purposely asked the image generator ChatGPT to get me a Venn diagram. It was able to generate this. Okay? So artificial intelligence kinds of encompasses everything. And within that, we have machine learning, and then we have deep learning. So maybe these terms, uh, you could be knowing it, but those who are not so familiar with these terms, maybe through this presentation, it becomes clearer. Okay. So ML is machine learning. In short, we call for ML is a subset of AI that focuses on teaching machines to learn from the data and make some decisions and predictions using the data. So there is also another set of machine learning algorithms called unsupervised learning. So when you use data to train an algorithm, it's called as machine learning. And within machine learning, you have supervised and unsupervised learning based on the type of data that you use. Okay. And what is deep learning? Deep learning is where it's not the depth of the knowledge you go through. Basically, how the idea comes about is humans have brains, and these brains are composed of is made up of neurons, and this is the typical structure of a neuron. So this is like the central processing unit, and these are like the inputs, the axons gets the input from other neurons to the current neuron, and it does some processing, generates a neuro signal, and that is transferred to the next neurons uh, through this path. Okay? So to mimic the function of the brain, then scientists have connected, artificially constructed this neuron, and then they collected layers and layers of neurons. So these are going to be neurons which are being implemented on the computer. And having such layers of neurons, when you train them right, it becomes deep learning. So that's how the deep learning comes in. Okay? So machine learning, artificial intelligence is the overall umbrella. Within that is machine learning, and within machine learning is the deep learning. Okay, all your Gen AI, generative AI, large language models are all part of deep learning. They are again a subset within deep learning. Okay. So what is the evolution that has been taking place in this AI field is we this neural networks was a few years back, around 2013, right, was like a big hype. Like, oh, machines can identify images, can classify items in image, was a big thing in 2013. But now when you look at it, right, it's just a piece of cake. Like it's not that fascinating. But when it was like 2013, right, people were like, well, missions can do that, but it doesn't mean that mission has got the intelligence to do. It has just got the ability, but it is not like it doesn't mean that it has the thinking capacity to make the decisions. That one we have to remember. Okay, so with neural networks, we had all these when you see these terms like ANN, CNN, and LSTM, all refers to neural networks. Some form of connected neurons, layers and layers of connected neurons, forming a network of neurons, and that becomes a neural network. Okay? So basically, when we are training an algorithm or anything, right, we are learning some parameters. Okay, so the parameters are like in layman terms, just assume like these are like knobs in a machine that you need to make it work. Okay, so the number of knobs that you need to have a realistic neural network doing some applications is 1 to 10 million parameters. As we have progressed, right, now we are talking about like trillions of parameters. So that's the number of parameters we are using it on to do some artificial intelligence stuff. Okay. So after this neural networks came the term LLM. LLM stands for large language models. Why this large language model, the term came up is because people were training data which were quite large. The amount of data that is being used to train these models is extremely large, and also the number of parameters being used for implementing such models is also quite large. So what fueled the implementation, the feasibility of LLM is the advances in semiconductors, because now we were able to get faster processing and heavy, I mean, we could storage large volumes of data at a cheaper cost. So the advances in semiconductors also fueled the implementation of neural networks and large language models. Anybody knows when was AI first started? Anybody can make a guess? When was the term AI or this mission artificial intelligence term first coined? Any guesses? 1980s, 1956. So it was there quite a long time ago, 1956. But it was just, sometimes, right, people say you are at the wrong time, the wrong place, right? So AI happened to be at the wrong time, because at that time, there was no 1956. The first computer, right? Well, the size of the first computer, maybe I give it as an exercise. You go and search for the size of the first computer, you'll be amazed by the size of the computer and what was the task it could do. Now your mobile phone, right, can do far more things better than what the first computer could do. Okay, so so the advances in semiconductor played a very big role in the implementation of these algorithms along the way. So we could do these computations, uh, I mean, quicker at a faster rate because of the advances in the semiconductors, and thanks to NVIDIA and the other chip makers. Okay? So what's the difference between neural networks and the large language model is that the neural networks were not able to like pay attention to the context. Sometimes when you speak, right, in English, when you are communicating with a friend, your friend is able to easily identify to which part, whether you are referring to a place or a person, in the context. So the context, right, is we are able to capture it when we have a normal conversation, but that was not feasible with these types of networks. So that's where people implemented a term called transformers with the neural networks, and then we could do large language models which were able to understand the context and able to give you a better response. Okay. Then from large language models, we move to generative AI. Generative AI is the one that I think a few years back, it started off with the chat GPT. Even before there was other generative models, but with the release of chat GPT, it became much more prominent. Okay. So any guesses of what GPT stands for? We will come to it later. Okay. So GPT, the generative AI kinds of combines the neural network and the LLM to give in some multimodal aspects. Okay. What do we mean by multimodal is, so far here is only text. Okay. So, but we want systems which can generate text, which can also generate images, which can generate sounds, audio, and so on. So these are like multimodals. So you're taking inputs, not only text, you're taking input, which could be an image, which could be a sound, and then you also generate text, images, and sound. So that becomes a multimodal input and multimodal output. So the generative AI systems are the ones that we have as the chat GPT, Sora, and so on. So these typically have billions of parameters that are being used to implement them. And the quite recent one, how many of you have heard about this term, agentic AI? Yeah. So this agent AI, right, is kind of the new buzz, right, where you use so far, these are all reactive systems. You prompt them, they give you an output. But this is more like an autonomous system. Basically, think of it. An example that I can give is the Jarvis in Iron Man. Okay? Sometimes the movies gives us, I mean, are way ahead of us in implementing certain things. Okay, so Star Wars had the 3PO robot, but now the robots that we see, right, the real time implementations of this 3PO is something like quite recent, but the movie came years ago. Okay? So agent AI is kind of systems where we are talking about autonomous, like they are able to monitor and make decisions on their own. They are no more reactive. It's kind of a proactive system And then people are also talking about multi-agent AI, okay, like a group of agents coming together to not solve a task, but to address a goal. Like maybe I want to keep the home safe, or I want to maintain an output of this industry at this rate, and so on. So it becomes autonomous. Okay. So the next one, okay, I guess this Turing test is a very important test in the computer society and those who are doing like machine learning and stuff. So this is the person Alan Turing. The test was coined after his 1950 paper, which was computing machinery and intelligence. So the main question that was asked is, when can we say can machine thinks? Okay, so he has a test. So when you subject the machine to test and it passes it, okay, then we call, okay, it has like it has the machine has considered to have passed the Turing test. So with the recent advances in AI and so on, are we able to say whether this test has been passed? So it is still debatable, but people claim that Turing test is not fully passed. It is, I mean, to a certain extent, it has been considered to be passed. So we will come to it later, like in the next slide, like when we can say that, okay, we have missions which clear the or which pass the Turing test. Okay, so the core question that how this test works is basically it's I mean, there is one judge who is going to interact with a person and with a mission. Okay, so it's not going to have a visual contact. It's going to be like a blinded interaction. And if the judge is not able to distinguish the actual person and the mission, then it is considered that the mission has passed the test. Okay. So this happened in 2014 again. I may be wrong with the year, where this Eugene Guzman, okay, is kind of an AI chatbot. It mimicked the 13-year-old Ukrainian boy, and it was able to convince like 33% of the judges that it's a human. Okay, so it's considered to be like a partial test, but again, when we consider machines, right? The missions is able to mimic. A set of people argue that this intelligence is all because of its mimicking ability. We cannot conclude that the missions are able to thinking and mimicking are different things. Okay, to give this perspective, right, imagine, would you consider to be good in mathematics, in calculations, when compared to that of a calculator? So some of the complex calculations that you do on a calculator, right? Your calculator is faster than you, but the logic behind it, what to compute, what to multiply first, what's the rule to follow, right? Maybe those things you are able to understand and interpret it better than the calculator. So that's the argument that one set of people, right, always put forward, claiming that missions are not able to pass the Turing test just because it is the compute power is vastly available and is able to do, I mean, digest or churn out, read through the large volumes of data and able to process quite quickly, doesn't mean that the missions are able to think. It appears that it's able to think, but it's just because there is a set of computations that are being done fastly. It gives us the impression that it's able to think. Okay. So sometimes, right, you have computer. I mean, now all your camera, your phones, right, able to group your pictures. So do you think the phones are able to identify you and understand you better? No, it's because they have the computational capability and able to see the patterns. Seeing the pattern is different from logically thinking. Okay. So that's the difference people always put forward, arguing like missions and still not able to pass the Turing test. Okay? But we can, but ultimately as an end user, right, the more efficient missions we have, we can use it for our assessments and stuff like that to make our life easier. Okay? So, so coming back, with reference to the Turing test, the based on capabilities, AI can be grouped into like three categories: narrow AI, general AI, and super intelligent AI. So predominantly, what people claim is we are here, narrow AI. We have systems which do specific tasks. So general AI, or the term AGI, if you come across the term AGI, that stands for artificial general intelligence, is where we would be able to have like an intellectual ability of a human. So we are still not yet there. Maybe we are halfway through, or I don't know. So maybe here we are at this stage, we are moving towards here. Maybe here, I don't know what's the outcome would be like. Super intelligent AI, there are a lot of things people debate about. Maybe we may see the Minority Report or any other the science fiction movies that's available, right, might become like a reality here. I don't know. It could be a positive or negative. We don't know. Okay, so this is where like missions outsmart humans. They're able to create, think, and do things. So this is, if we achieve here and here, right, definitely. I mean, it's beyond the Turing test. Okay, so let's move. Okay. So when we delve into the concept of AI, right? So you'll see these animals, llama and this bird, emu. So you know why this animal comes in? Any guesses? Things you know? So this is like is an animal called, the name is llama, but in AI there is also a model which is called as llama model. Okay, and this is a emu bird. We also have emu in AI, but it is not a bird. Okay, it is called as okay. I will come to it in the next slide. Okay, so the based on this large language models, right? So people started with neural networks, deep neural networks. Then we had large language models. So each company, each organization have their own. I mean, what do you call releases la, or implementation of these large language models. Okay, so this is Chat. The GPT is from OpenAI. Llama is from Meta. So it stands for Large Language Model Meta AI. So this Facebook, right, Meta, wanted to stand out. So that's where it coined the name llama, so that it is in line with that animal, which is known for its strength and agility. So that's how it got the name. Okay. Emu was also coined in the same way. It was immersive media universe, extensive media universe, because EMU is also a model which is from Meta AI. It is used for more of generating images and videos. So that model is also from Meta. So these two things, right, comes from Meta. I mean, from Meta is I mean, Facebook changed to Meta. They developed these large language models and the image generating models, and they named after these animals and birds. Okay. So again, you know, the news, there was this DeepSeek. I think many of you would also be doing investments, right? So Nvidia and other chip makers took a deep. I mean, the stock prices fell deeply when DeepSeek came into the market. Okay, and this is a bit different from the other models because it is able to have a concept like the mixture of experts. Just think that it is combining. It has an attributes to achieve the same performance with less number of parameters. Okay, so it's like when you are going to give, in layman terms, right, if you're going to give a job to a vendor, you will be getting quotes from them, and you will be going with a person who gives you the best price, right? So out of all these computations, right, so DeepSeek was able to give a better performance with less number of computations. Layman terms. I'm not going into the details. So that's where it became popular. And then when other models were using large number of parameters, I could do it in a in less number of parameters. And that's caused like an impact on the stock market. Like, what are these chip makers doing with? We don't need so sophisticated chips, and that led to the fall in the stock price. But I guess now it's again up. Okay. And this model again is Anthropic is an organization which has released the cloud model. The cloud model, the name comes after the scientist Claude Shannon. So Claude Shannon is known for the pioneering paper in information theory. So information theory is the backbone through which we are having all these communication possibles. The representation of message in terms of ones and zeros stems from this guy, Claude Shannon. So in respect of that, so this Anthropic named their model as Cloud. So these numbers, I think it refers to their versions. Again, Google DeepMind named their model as Gemini. Does anyone know why it's called Gemini? So the Gemini again, right? It's an astrological name, right? It has two characters. If you look into the Gemini, the symbol, it has two characters. So since this is a combination of LLM and neural network, right? And transformer, it got the name Gemini. So two entities coming together to give a multimodal generative AI. So these are LLMs, but the ones which support multimodals are the GPT and the Gemini. Yeah. So what does the GPT stands for again? It stands for generative pre-trained transformers. As I've said, the transformer was the key differentiating part, which led to machines to have like a contextual conversations. Like they were able to chat like humans because of the use of the transformers. So the transformers were not present in the neural networks. With the recurrent neural networks with the transformers, then we went into the large language models. So the generative AI here is where we use the multimodal support. So GPT now can generate text, image, and even audios. Then this Sora and DALI, right? The other things we have seen, the 4 and 5. I asked ChatGPT to rank the best generative AI. That's how it came. So don't if you are like you ask me why I have put DALI as number 5, right? Okay, it comes from ChatGPT. Okay. So Sora again, right? How many of you know Japanese here? Anyone knows Japanese? So Sora is a Japanese word for sky. So the OpenAI say that the sky is kind of limitless, right? So it says that this model will open up limitless opportunities to the world. So that's why their model, right? They named it as Sora. So basically now it's used video to text and so on. Okay, mostly for annotations. Again, the DALI, again, the name came from, there was this artist, Salvador Dali, and then the Wally robot. Okay. So since it's able to generate images, right, artistic images created by a robot, then the OpenAI named it as DALI. Okay. So when you come across these terms, right, again, it's don't. I hope through after this presentation, you know where it comes from. So always go back to, it comes from here, from neural networks. We move to large language models, generative AI, and by the time in few years time, right? I mean, I cannot say in years. Now it's weeks and months. It will be multi-agent and agentic AI and stuff. Okay. So how many of you have come across a term notebook LM? Okay, have you used it? Okay, so again, it's my favorite part of LM. Okay, I'm not advertising for Google. I'm not from Google. Okay, but a notebook LM is from Google, and basically what we see is when you do a Google search, right? When we started off, when you want to know about anything, the go to do thing is to go and do a Google search. Now the to-do thing is to go and ask a chat GPT. Okay. So, but what's the problem with these type of approaches? Because Google and chat GPT, right, Google brings everything under the whatever is in the internet, right? It brings it to your browser. And ChatGPT is much more refined, but it's still all over the place. But sometimes you want information within a particular domain. So what happens is, let's say I have a book. Reading a book is kind of going to be very, very. I mean, it's going to be taking a long time. Okay, depends on the purpose. Some of you might be avid readers and might finish the book in a short time. But if you want to know the book and but you don't have any time to read it, you put the book, which is in PDF or whatever format, right, into the notebook LM. It generates a conversation, like two people interacting. I urge everybody go and try notebook LM. Okay, you will have a different perspective about it. Now you can, once you have that audio file, right, it is like a podcast. You can download it to your mobile device and you can listen to it on the go. Like you don't need to read the book, like just as a conversation, right? Any document, you can try out with any document. If you have a difficult time reading a document, putting it into a LLM, then it kinds of churns out a audio podcast to you. Okay. So, and you can also ask questions like the chat GPT and it will answer it from the context of that document. It will not go beyond the document. So whatever the questions, right, it will try to search for answers within the set of documents that you have uploaded into the notebook LM. So I urge you to go and try out today. Maybe then you will have, I mean, it will be very useful to you. Yeah. So next about the data. Let's move on to this data. The AI stuff is over. So the data again, right? We will go into the types of data and then what's happening with the data in the recent times, and then we'll move to the IoT system and we will conclude. Okay, the types of data that we are dealing with, we know is structured data, unstructured data, and semi-structured data. So structured data is all those tabular data formats, the Excel sheets that nice. It has name, column, serial number, and so on, defined labels and formats. So that forms the structured data. But predominantly, right, the most of the time, what we get is unstructured or semi-structured data. So unstructured data, the examples are image files, audio files, some email, social media posts, Twitter posts, and so on. Do these forms unstructured data? There's no like definitive format. So it could be the duration could not be fixed. Maybe it could be of any duration, any length, and so on. Okay. Semi-structured data, some examples are the JSON, XML files, and other documents. So these forms like semi-structured data. So these are the types of data that we have. And then when we run a machine learning algorithm or we are developing an AI system, we need to work with all these types of data. And the typical life cycle in a data is where we create or acquire data, we store them, we do the processing, processing in the sense cleaning and some other additional processing that we do. Then we use it, and then once we have used, we have to dispose it also properly. This is the typical data life cycle management in a data. Okay. So the big data, what we classify as big data is through the three V's. Okay. When do we call a data to be big or a big data is when the data is too complex and it cannot be handled by the traditional databases like Excel or your SQL. When it cannot fit into these things, then you're dealing with big data. Okay. So big data is characterized by the three V's. In fact, people talk about five V's. Okay, the three V's are volume, velocity, and variety. Okay. So do you know how much volume? Okay, the size of the data, right? Okay. Sorry. So these are the sizes. Basically, the maximum size that we have on our laptops is in terabytes, right? So 1,000 terabytes makes a petabyte. So 1,000 such computers that you have, or 500, okay, because the Mac is 2 terabyte, right? So 500 Macs will become 1 petabyte, and 1,000 petabytes makes 1 exabyte, and 1,000 exabytes makes 1 zettabyte. Okay. So make a guess how much information we generate in a year. Is like 463 exabytes. That's the amount of information we are generating now. And thanks to the semicon becoming cheaper, we have more devices than the number of people on the earth. Okay? It's going to increase. And the volume, the velocity at which we are going to produce this data is like 7 petabytes per second by the next year. So people estimate that, sorry, by 2026, we would be generating like 7 petabytes of information per second. Okay, so that means we need to have some mechanism to quickly store and process this amount of data. Okay, so that's the big data that we are looking at. Okay, volume, velocity, and the variety, because now data comes in varied formats. It could be text, it could be tweets, it could be images, it could be audio files, and so on. There are different formats. So these are the three main V's which classify the big data. If you look around, it will also have additional two V's. One is the veracity, and then the value. Veracity is with this data, right? Sometimes now the biggest thing is fake data. People fake a lot, so you need to also have mechanism to identify or to take into consideration that the data might be like like faked. Okay, you have to deal with it. Okay, not, you cannot assume that it is 100% true data. Okay, and then the value is the amount of I mean, it's the insights that you create from these big data. That's going to be the value. So with this big data, there comes the ethics part. The biggest one, which is well talked, is the privacy. Okay, so a lot of times we just agree the terms and conditions because there are so many and they are so small in size, we don't even pay attention to it. But again, there goes your privacy too. Sometimes they may just say, we will be tracking this. If you agree to it, there goes all your data that you create using the app is being tracked. Okay, so always it's good to practice good principles when you implement AI systems or machine learning algorithms to get the consent. Whenever you are dealing to collecting data from people, tell them for what reasons and for what purposes you will be collecting the data. Okay. Then the bias and discrimination is kind of um, it's a known problem that needs to be addressed too. Okay, because sometimes your data can be skewed. You may not have enough representation in the data, and that might impact your inferences that you generate from the algorithm. Okay, so if you for example, if the a particular set of people they don't get loans, then when they come for a loan application, right, since you didn't have enough data about that particular sect, right, then you may be the algorithm, not you, the algorithm might recommend not to give the loan. So these issues are there that needs to be still looked upon. So surveillance, again, because there are so many cameras running an AI algorithm in the background, right, is just a piece of cake. And using that, right, you can be tracked anywhere you go, right? You can be tracked. So again, I mean, this was in Singapore context. I'm just citing it. For example, there was this. We had this during the COVID time. The beacon could track people who are nearby, right? That was indirectly used to capture someone, right? So that kind of surveillance, right? It's still possible. So there needs to be proper care in place to ensure that these things are not doesn't invade the privacy of the people. Who owns the data is also a big question. When you upload your contents onto any platform, right? It belongs to you or belongs to the company. So how they want to use it, again, it needs to be properly looked into. Transparency, whenever people collect data, how it is being used for needs to be clearly outlined. If not, it's going to it'll be, I mean, it may have some unforeseen consequences. Basically, when we make a decision, right, we are able to logically reason out why we are coming to that conclusion. But if you get the inference from that of an algorithm, can you make the same inference? Can you make the same can you get the understand the logic behind it? So that's where xai is becoming popular, explainable AI. So why the algorithm is recommending such a decision or making such a decision. So these things are the ethics that come about with big data. And of course, we know there are frameworks that are being worked on. We in Singapore we have the PDPA, which deals with this with the privacy of the data. GDPR in Europe, and the AI ethics guideline is promoted by the OECD and the UNESCO and major AI research bodies. So now to the IoT. I think I only have a few minutes, but we're almost there. So IoT is now nothing but a system of interconnected devices, and an IoT system is able to collect, exchange, and make decisions through the internet autonomously, but maybe it could also do at a very faster rate than the humans. Okay? So basically, any IoT system will comprise of sensors and devices. It will have some connectivity, will do some data processing, and then it acts upon. Again, IoT system has become popular again due to the advances in semiconductor. If let's say every device is going to become going to cost you $100, nobody would implement an IoT. I may just pay someone to go and monitor it regularly. The manual charges would have been cheaper, but now due to the advances in semiconductor, the IoT devices are so cheap that you can do a lot of things. Even if it goes faulty, right, you just replenish with a new one. Previously, there used to be a time where I used to repair electronic devices. Now you hardly see anyone repairing. If it is faulty, throw it, get a new one. That's how cheap it has become. Okay? So connectivity is something. Okay, the device connectivity. Oh, sorry. The connectivity plays a very important role, because why connectivity is important, because you want to have the communications done at a faster rate, and also at a higher the throughput, the volume of data that you want to transmit, it should be large, and the rate at which you want to transmit should also be fast. Okay, why? Because we are talking about autonomous systems, autonomous cars, or maybe unmanned aerial drones and so on. Imagine you are going to have a delay of 1 second, or in sending some, instead of turning left, you should be turning right. It could cause a major disaster. So that's where the connectivity plays a very important role. And the number of devices that needs to be connected should also be more. So any guesses, like in 5G, right? All of your phones are 5G. How many connections can we have in a 5G network in one square kilometer? Okay. 1 square kilometer, right, is 1 million devices. That's the 5G connectivity, okay, we are talking about. We already are at 5G. We are moving towards 6G. And 6G is already in play. I mean, the progress is going on, and people expect it to come around 2030. Okay, so it has its own. Even to give you a perspective, what's the population density of Singapore per square kilometer? How many people are there in Singapore? Singapore is considered to be highly dense. How many people you expect to be in 1 square kilometer in Singapore? I'm not smart. I also got the information from. Yeah, okay, so this is how good it is in getting an interactive presentation. Okay, so it's around 8,000. So in 1 square kilometer, right, you have 8,000 people in Singapore, and we are looking at 1 million devices. Okay, so so even if a person has thousands of devices, right, then only you will hit that limit. Okay, so that's the advances in semiconductor and the communication that has paved the way for these growths in AI, data, and IoT. Okay? So, so some of these examples, some are already in place, like consumer IoT. We have smart shelves. I mean, the cold storage. Some point of time, when you put the things into the basket, it automatically churns out the total bill for you. So those things are examples of consumer IoT systems. Commercial IoT, industrial IoT, smart city, and so on. There are a lot of agriculture, of course. I mean, when we do vertical farming, we will also have to use a lot of sensors to monitor the crop growth and the soil growth and so on. So, I mean, I'm not going to cite the examples now because we almost only have like 15 minutes. So combining these things together, AI, data, and IoT, we have like it's almost like an artificial intelligence of things that's going to drive these four things. We will be able to make real-time decisions quite, I mean, in real time, making decisions in real time is kind of like it's almost happening now. And we're going to have increased automation and improved efficiency. That's going to come up with this real-time decision making. So we are not going to make anything like reactive. We are going to be more proactive in stuff. Okay, since we are able to to analyze the data and make decisions quick, it's no more reactive. We won't wait until a thing happens. For example, if the AI would be able to tell when the machinery is going to fault and then do some preemptive maintenance on that. Okay? So because of this, we're going to have improved safety and personalizations. I think personalization is something kind of it's going to be. I mean, it will play a vital role because I mean, one crude example, what I can say is few years back, people used to only be connected to the TVs. Now, hardly people watch TV. At least in my family, all this YouTube and TikTok and other social media platforms. And even that, right? You have a vast variety of people churning out content. So you're not like uh, you're limited by the choice of channels you have. You can make a decision like what I am going to watch and how I'm going to watch. Okay, so that kind of personalization, right, is going to happen quite drastically. The future trends, of course, there are a lot of things happening, and in the interest of time, I'll just focus on this tiny ML and federated learning and the okay. What do you mean by federated learning? Right, it's an important concept to you see. So far, all the training is done in one place. You upload your data in the cloud. The cloud service provider gives you a suite of algorithms which you can apply on the data to churn out the results. But it accounts to collating all the data in one place. Sometimes your data could be distributed and you will not be able to collate them in one place due to security reasons or some other reasons. In that place, right, you need to train a model in a distributed way. And that's what is federated learning about. So that is going to play an important role too in the upcoming days. And explainable AI is also quite important because we don't want to have a black box. We want to know the reasons behind why an algorithm is making such decisions. Okay. Multimodal AI is already there, but moving forward, with the advances in the multimodal AI, maybe we will have more human-like interactions with the systems. The future trends, again, this is sometime back. If you are going to implement something, right, after the ideation phase to collect the data, it takes about 1 month. This is, I took it from a recent talk by Andrew Ng. Okay, so to train the model takes another 3 months, and to deploy it takes another 3 months. But with the LLM based approach, right, you could literally deploy a model within a month, like 3 days to collect, I mean, to specify the prompt and do the stuff, and then 1 week to deploy it. So that's how fast you can churn out. It's no more like waiting for what's best for my customers. I will churn out thousands of models, and whatever, right, is the survival of the fittest. Whoever, like, based on the interest, right, people will select different things, right? There goes your personalization too. And that's possible due to the advances in the large language models. Okay? So the bottleneck is no more in the model deployment; it's more on the evaluation and the other stuff. Okay? The deployment is going to be quite fast. Okay? So the risks and challenges there are quite. I mean, we have seen it. I'm just the data privacy is a big issue. The bias we already seen it. The interoperability, of course, when people develop systems, right? I mean, a crude example is most of the time our Apple devices are not compatible with others, be it cable, charger, or other thing. Even to add drop, right? You can only add drop to another Apple. So those things, right? I mean, it's a crude way to explain interoperability. Can also happen with the algorithms too. So we don't want to have such things with the AIoT systems. Of course, I mean, those things, the one I highlighted in yellows are the one I think is quite significant, need to be carefully looked upon. So almost to the last, so I know I've given a quick intro to this topic. If you are like still, I mean, you're excited and want to, I mean, there is no way like after I finish, I can just stop. It is a lifelong learning in this field. Maybe in certain fields, you learn the basic, you can run with the basics alone for a long time. But this one, right, the way 1 week, every month, you'll have new things. But to get started, you need to start somewhere, right? So at SUSS, we are offering these postgraduate programs. It's a graduate certificate and graduate diploma, 3 courses for the graduate certificate and 6 courses related to AI, data, and IoT that you can consider. So we are open for admissions for the Jan 2026, and our application timeline is, if you're interested, submit by 15th October. And yeah, that's the barcode for the application. And if you have any questions pertaining to this program, you can always reach out to me. Okay, I will put in my name. Okay, in summary, right, IoT devices generate the data. The cloud is where we store the data, or it could be also edge devices. Because now with the advances in the semiconductor, we can have good storage even at the edge devices. Cloud is like a central storage. Edge is like at the peripherals, right? Basically, your phone, you are able to do all your AI stuff on your phone too. Okay, so that phone forms like the edge of the device. Okay, and AI is able to process and the data at a very fast rate and give out some inferences. So AI OT systems would be like an autonomous system which acts without any human intervention, but faster than humans. So that's the summary of what I mean, key takeaways that I've crudely put it up. Concisely put it up in the last slide. And thank you for your attention. Maybe I'll just go to the first slide to give my email ID, just in case if you want any questions or reach out to me. Okay, yeah, that's my email. And if there are any questions from the floor or also from the online participants, yeah, be more than happy to address them. Thank you.
For the insightful sharing. So we'll now open the floor for Q&A. So you have any questions, you can raise your hands and I'll hand you the mic. For those online, you may use the Zoom Q&A function to post your questions.
My responses will be slow because I don't have the GPT or the large language models with me. But soon, right? In few years, maybe we'll also have. Now you have the Zoom, which generates the summary of the meetings. It's all possible because of AI. Soon we may have like a Jarvis sitting behind the back and prompting, "Hey, answer like this way." That's the answer. Okay. But now I don't have. Yeah. Yeah. Okay. Yeah. Yeah. And if I toggle the screen, sorry. Okay. I mean, for machine learning, right? Python is the default, and there is a question in the Zoom. Is there a minimum requirement, say, need to knowledge in coding to embark the journey? Coding will be inevitable. You have to do coding, but I mean, when we started off, right, I started to teach machine learning for the undergraduate students in SUSS. We used Google Colab. At that time, right, we need to type in every code. Now, right, with the AI in place, it prompts you based on the data or or the items that you have typed before, right? It is able to prompt you the next line of code that you need to put in. So coding is inevitable. You have to deal with coding if you're going into AI stuff, but it has become far more easier. Okay, yeah.
The coding part. Thanks. Um, yeah. How I think most people they want to learn, but like for me, I'm not really scared. I
Okay.
actually have some basic coding, but when I encounter a course that
Okay.
is like very coding how do you call that, intensive, I tend like to no, this one not for
Okay.
me. So
It's a good one, but what we do is we also give like coding templates. Coding will be there. I would say at least 60% of the course would be coding. Yeah, yeah. So yeah, but we would be giving the coding templates to get the students started with. Okay, yeah. Yeah, the security, there are, I mean, if when there are a lot of, when you have an IoT system, the question is what security issues are there for AIoT and what are the controls? As I've highlighted in the presentation, right, the security could be from the end device. Okay, basically you could have a secure premise, but when you have like a IoT device which doesn't have the the necessary protection, right? People always can go through the weakest link because when you have the IoT system, your IoT devices would be your weakest link because they would be exposed to the environment. So, I mean, this was, I mean, my friend cited this example. There was like a company in the US which had an aquarium, and it had a very secure system, but the someone deployed a sensor to monitor the fish and the water quality in the aquarium. Okay, so in spite of having this a very secure system, the IoT device to monitor this the aquarium, right, had the flaw, and the hacker went through the IoT device into the network and then hacked the system. So always the IoT sensors, right, could be the weakest link, and you have to make sure you have the protections and firewalls in place to take care of it. Uh, I I would like to know how we can harness AI tools for uh, career related search. Um, I mean, um, I'm not so sure if I'm getting the context of the question correctly, but uh, again, with this generative AI stuff, right, it's able to help you in a lot. Writing from a cover letter, in formatting your resume, and also matching you, right? If you have your profile already on the LinkedIn platform, it prompts you with the jobs that are relevant to you. It's already happening. But what you can also make use is, I mean, that's where the prompt engineering comes into a bigger play. Okay, so prompt engineering is where you ask and you train the generative AI to aid you in having a better standing out cover letter or a resume. Said that right? AI, the employer also has access to the AI. Okay. We can also screen out for participants who use AI and stuff. Okay. That can be both positive and negative. Okay. At least I know, okay, this person, right? Looking at if I get two profiles for a job opening, I see a person who has done like not so good work, but it is original. And second one, right, is it is fantastic and use AI. It depends on my perspective. If I am a person who is looking for a candidate with tech skills, right, I will go with a person who has used AI. Okay, but if I had said cannot use AI and you still use AI and apply for the job, then it's a no go. Okay, so that's how it can be used. Okay. Um, what IoT hardware models will be used, such as Arduino? Arduino and Raspberry are kind of good kits that we can start off with, but we need not be restricted to just using Arduino or Raspberry Pi. Okay, there are other kits too, but in our program we are planning to use the Raspberry and Arduinos. But you won't be. I mean, we initially had some hardware courses, But again, we know for for professionals who are going to upgrade, it becomes a bit tricky to get started with hardware. Like programming itself, you say no, but then hardware to solder and joint circuits is going to be a bit tough. So we may use emulators and we just show them. So most of the time, you'll also be at a stage where you are going to bring in the IoT systems and not just do hands-on design. So we want to fit it at that middle level. So this is the last question. This course is a full-time or can be taken part-time. The graduate diploma and the graduate certificate are only conducted in the evening, so you can do it in a part-time mode. Yeah. Okay. Thank you all for being the wonderful audience and listening to me. Thank you. Thank you.
Thank you so much, Prof Lokesh.
Thank you. All the best.
Has been a really insightful session, and thank you for trying to answer all of the questions that we have on hand.
Thank you. Thank you. Have a good weekend. And the next sessions are also informative. Yeah, thanks.
Thank you everyone for joining us today. If you are leaving after the workshop, do scan the QR code. Okay. Yeah. So can you share us your feedback for this? Also do check out the book that we have outside, as well as redeem the free drinks and ice cream. Yes, by following NUS scale on Instagram. Yeah. So enjoy the festival. Thank you.